All right, so before I get started, does anyone have any questions about anything that we've been going through, anything that's coming up?
Just one quick question. I'm always the one, maybe.
All good, no worries.
No, so are you going to cover some part of GitHub also today?
So not today. Next Thursday, actually, when I introduce the project, I'm going to talk about GitHub again and how we're going to use GitHub with our project.
Okay.
Yeah. So we're going to talk about GitHub more in that context. So we'll get a little more practice that way.
Okay.
Yeah.
Uh,
Yeah.
uh,
Anything else?
what are the sections that we should go over for the project again?
For the project, definitely, it's going to be a lot of 4, 5, and 6. I'd say like you can get through all of the project if you work on getting your data with pandas, data cleaning in pandas, and also making visualizations. There is an option to use this section, actually, section 9, to get more data. I was telling a couple of you that like for the project, basically you're given a bunch of data sets in the form of CSVs, and you just have to do some sort of analysis. With that said, that data that you're given is intentionally really messy and a little bit hard to work with because of like missing data or like just not in a great format. So whether you like this stuff or not, section 9, what I'm going to talk about, you can choose to actually get your own data. And so you have a lot more control over how your data looks if you decide to use an API to get your data on your own. So it's definitely an option. But yeah, it's up to you. So it's either you're practicing more with pandas or practicing more with using APIs. I will say that you're probably going to end up using APIs almost certainly, either using an API or web scraping, which is next section, to get your data for future projects. So it's up to you whether you want to practice that now or focus on data cleaning with pandas first. But of course, like, you don't have to make this decision now. The project is up on Learn, so you can take a look at it right over here. And you can read the prompt and sort of explore what is there to see whether you want to see which way you want to go. Yeah, that's a good question. Anything else? Cool. Very quickly, because I realized that I don't think everybody knows this, is that on our channel we have, on our class channel, we have Matt Spar and Ben Jacobson, who are always like saying hi every evening. So for those of you who don't know, they are actually Flatiron technical coaches. So they are actually here to answer questions after hours. So after I'm done working at like 6 or 7 Eastern time. So if you ever have questions like at night or sometimes on weekends, feel free to send them a message. It would actually be most convenient if you put your question in the channel and like tag one of them. And it's their job to answer your questions or to help you out. So definitely use them as a resource if you didn't know that was available. Because I know I don't always answer questions at night and also over the weekend. So they are also a resource if there's something that you're working on. So definitely know that those two guys are great resources. Cool. So section 9 is on JSONs and APIs. So I would break this section up into like two main points of the section is JSONs, which is a file type, and APIs, which is this whole other realm of like, for our purposes, is a way for us to get data from the internet. And so how the labs are structured is you have these first 7 labs talking about JSONs. And as you're going through them, you'll see that a JSON is basically a large nested dictionary. So going through a lot of this stuff, I'm going through like the first half of this section will be, I think, mostly review of section 3. I know since we've dove into pandas, we haven't gone back to like coding with Python that much, but these labs will be, yeah, more along those lines. And then this half is actually a lot of reading. So like I think 1, 2, 3, 4, 5, I think, is just more like theory and more like technical about how an API works and how that fits in with that whole like server cycle. So feel free to read that, but it's not super important for us to like know all the terminology for sure. For us, the most important part is that we know how to use an API to get data. And that's really just like this part where it's actually, I think these are great labs that you're using Yelp's API. And I just think those are good like code along labs because it's sort of like a mini project rather than a code along, but it actually shows you how you would use an API. And fun fact, my capstone project, I actually used Yelp's data. And so it was very, very helpful that this lab was here.
How do you pull Yelp data? That's what we are.
That's exactly what we're going to talk about.
Oh, great.
Yeah. All right, so I have this notebook here, and I'm just gonna, the way this notebook is structured is really just like taking the bits and pieces from all of those readings, summarizing it to what I think is most relevant, and then we're gonna do an example of getting data using an API. Cool, so let's get started. JSON is a file format. It stands for, damn, what does it stand for? It stands for, off the top of my head, I don't even know. Let's Google it.
JavaScript something?
It's a JavaScript object notation.
Yeah. JSON stands for JavaScript object notation. I don't know why I thought it was in the notebook, but it isn't.
I don't know what it has to do with JavaScript though.
Yeah. Yeah, because in JavaScript, they use a lot of dictionaries. Like most of the data of their data looks like it's in dictionary. So I think that's kind of why. But JSON is a file format that is readable by all sorts of different coding languages, which is why a lot of data is given to you in a JSON file format. So yeah, a JSON is a data type. It's a data file type, as like a CSV gives you like tables. JSONs will give you these large dictionaries, and it's basically like very similar to the kind of data that we would put into something like MongoDB. So with any data set, you have a schema, and a schema, as we've seen with SQL, very, very useful in helping us see like what's going on. And so this is an example of a schema. This particular schema comes from the New York Times API. And it is, I believe, just like all of their articles, because they have an article API where you can just go and make a search for, let's say you want to do a project looking at like New York Times articles published about like food or something. You can do a search for that, and then they'll return all of your search results in this format. So you can see there's like a response, and nested in that you have the docs, and these look like these would be like the information of the article here. And then you have more nesting, and then you have also some metadata, and this is, I believe, in line with the docs. So I think it's pretty important to like get used to reading schemas, but of course, like it's important to also explore it on your own, because sometimes from this, it's sometimes vague to know what's going on, especially if you're not familiar with the data source. So let's take a look. To use JSONs, and as you can see here, JSON is saved as a .json file, and it lives over here, nytimesresponse.json. As I did with section 3, the first thing I like to do is just really explore your data. And so to begin, this is how we read in the file. It's like basically like pd.read CSV, but the JSON version, json.load. And we've loaded the data and saved it. We've loaded the JSON file and saved it to this variable data.
Can I ask a quick? All of the exercises do that in 2 steps. Is there a reason to do that in 2 steps and not like put the first line within the parens?
Yeah, I feel like this is just like the standard way of doing it. I don't know. I feel like there is a one-liner way to do it, but usually you want to have an open object and then load from there. That is just the way that we read data. I honestly haven't really thought about it too much, but yeah, the most data types that I've seen that aren't like CSVs or like anything that's like easily read with like pandas or SQL is in like 2 lines where you have an open object and then you load in the data. Yeah, that's a good question. I honestly never really think about that much. Anyways, So once we've loaded in the data, all of the data that we've gotten from that from this data file is saved to this variable data. And as I like to do with just print statements, take a look at what's going on. So data, as I mentioned, is a dictionary. And here we can see that we have the dictionary keys, status, copyright, and response. And so just based on, I guess, experience, you sort of can guess that all your data lives in response. So let's take a look at just data. Let's see. So status is just okay, because sometimes it doesn't work, and we'll see why later. You have some copyright information up here. And then response houses what you were actually looking for. So let's take a look at response now. And as you can see, what I'm doing is very similar to what we were doing before with like breaking up the nested dictionaries. So this is all that's in response. There's a lot going on here. So let's just take a look at the keys, because response seems to be a dictionary. So we have docs and then we have meta. And so docs and meta, that sort of matches this thing now, right? And so based on like my knowledge of this, this schema, I know that what I want is actually in docs, and meta just has like metadata. So now that we know that the stuff that we want is in docs, let's take a look into docs. So cool, seems like it's a list. Let's double check that. It is a list. I guess other than this, we can check for the length. All right, there are 9 docs in there. And what I always like to do is just take a look at that first one. Cool, so this seems to be all the information for one article, right? Like you have the URL for this article, snippet, abstract, the headline, and stuff like that. Just out of curiosity, there was docs and there was also meta. Let's take a look at what meta said. So meta, as I guessed, is the metadata, how many people read the article, I'm guessing, and also, I don't know what this time is, but for what I want, I don't really need this data. So I can just focus on the docs key. So here, we're loading specific data. I know after exploring that I want the information that's in docs. And just out of curiosity, let's take a look at what information is housed under docs. So as we saw earlier, there's web URL, there's like an abstract, headline, keywords, publication date, kind of document, ID, word count, and a score. So cool. Let's save all of the docs to a variable. And just to check, it's a list with 9 that we saw before. And let's print the headline of each thing, because I just want to see the headline. So turns out headline is another nested dictionary. So here, just by eyeballing it, I'm guessing that the main headline comes under main. Yeah, this is where the main headline is. And then this is all just other information that I guess is not important to me right now. So let's just print only the headlines. Cool, so now I have all of these headlines from this JSON file. This /n is just a new line, so that's why we have like a good spacing in between each headline. That's just for formatting on your Jupyter notebook. So yeah, so now I have these headlines in this clean format that I can read and see what was going on in this data. So cool.
One quick question. So now, when you found out that the headline is by the quotes which are there, that the total headline will be the same.
This part.
Yeah, I mean.
Yeah. So each headline. Let's see. I figured that each thing that's being printed is this entire dictionary, right? And I figured that this is too much. This is too much information for me. I don't want to see all of this other stuff. And what I want was what was under the key main.
So that's where, like, where the quotes are. If you see, right, it starts with from there it goes all the way till
Yeah.
So that's the only part which will be the headlines.
I well, it is what is under main. So I'm just guessing that that is the headline. Like through exploring my data, I'm just gonna assume that that is the headline. Yeah.
Okay.
Yeah. Yeah. So for this second one, it would be, this is the headline. And because just like looking at all the other things, it doesn't make sense that those are those wouldn't be the headline, because it's like none, just numbers. And so therefore I want what's nested under main. Cool. So, oh, did you have something else? All right. So we can also take these JSON file formats and throw them into a data frame. So I forgot if I've mentioned this before, but data frames you can easily turn a list of dictionaries into a data frame. And as long as a key, any key that exists in any of the dictionaries would be turned into a column. So here I have, I'm doing a import pandas SPD. I have the data frame here, and what I'm feeding into the data frame is this data response docs. And data response docs is the list of, these 9 articles with all their information. And so just like that, you can see that, all right, I have the web URL in this column, snippet in this, abstract here. The downside is, if you have nested dictionaries, the entire dictionary is going to be in a single cell. And we're going to look at cleaning that out right after this. But as you can see, every key that was on that first layer here got transformed into a column. That's pretty neat. So if you have a list of dictionaries, it turns really nicely into a data frame. And now that we have this, just to look into, like, for example, I know that I want the headline to be a column. And now that I see like the headline is like this, just checking that, all right, in the headline is a dictionary. And so if you're working with JSONs and APIs, in API, you get this kind of data. What you often have to do is break out this nested data. This is not the cleanest way to do it. I wrote this, like, this is not the best way to do it, but it does the job. So depending on how exactly you want to break it out, in this example, what I want to do is I want to create a new column for each of these nested keys and just have that in this data frame as well. So ideally, this wouldn't just be headline. This would be like headline main, or let's look at this. Let's look at this again. I want the columns to be headline main. I want headline kicker, headline content kicker, headline print headline, and I want all of those to be their own column. So in this code, this is not the really important part, but first I'm going to create a list of new columns, and then I'm going to loop through the keys of DF headline. So I'm going to loop through these keys, and for each key, create a new headline that is headline underscore these keys. And then I'm going to use a map function to just create those new columns. So really quickly, you can see that this mini data frame that I've made here is all these it's all the nested parts broken out into its own layer data frame. And all I have to do is just put it back and stick it with this and just concatenate it with this. Any questions?
Now, if instead of converting this into a data frame, if I just want to convert it into an Excel file, then just download it and just have a clean view, because then how do I do it?
I mean, ideally, as a data scientist, you never want to use Excel ever again. Okay. But if you want to put this in an Excel file, you would still have to extract the dictionaries from here, do all of this, and you would have to make the data frame first before you put it into an Excel file.
Okay.
Mm-hmm.
So can you just show the code real quickly how you would drop that into the main data frame?
Oh, yeah. So right now, let's see, I think I overwrote the variables. But let's call this Oh wait, just kidding. That's just, oh, I see what I did here. So what I did here was, this is just df of new calls. So what I did was I actually already added each column to the data frame. So if I look at the full data frame, it has all of them. So here, I still have this headline that I can drop now, but here you can see I have all this headline data. So what I did here was I was actually taking the original data frame and just adding new columns. But if I were to, let's say, like concat it, I would use the pd.concat function. Let's see, pd concat, and just put them together, stick them side to side. And I believe you can do this like, not like this, but like this. Nope, that's inner join. Let me just do it real quick here. Let's call df2 is df new calls. And then I'm just gonna take df being this smaller one. So let's print df2 here. Oops. I see what I did. So this is df2. And then df, I'm gonna take df here. So this is df, which doesn't have those extra columns, and df2 is here. And all I would do is do pd.concat. I think it's just df. No, I think I need double df and df2. And that is not right. I need these brackets. There we go. And so if I just put the two of them like this, x is equals to 1. Yep. If I do x is equals to 1, you can see that it's just it took the two data frames and stuck them side by side. So that's how you use the concat and stick them together. All right, so finally, just quickly to talk about how you can output things to JSON. This is especially helpful if you like are creating like a giant dictionary and you don't want to lose it. Similar to writing like pandas.toCSV, you can output things to JSON, and this is the syntax. Again, you have this open object, and then you're dumping whatever data you have. So here you can see that there's no like output file. So let's say I like, imagine I made some new data frame, but I'm just really gonna dump the original data file that we had. But if I run this, you can see immediately we now have this output JSON file here. That just shows how you can save a JSON file. Or if you have like a giant dictionary that you don't want to lose, you can save it as a JSON file. So there, that is JSON.
One quick question. Every time I make a database, data frame, and then like if I just rename each of them and then convert it into a JSON file, then what happens?
No. So I know this is a little bit of back and forth, but you probably wouldn't take a data frame and turn it into a JSON file. So this is just to show that like if I had this kind of data and I want to save it, I can use that JSON.dump function. But if I had something like this, if I had a data frame, it would make more sense to save it as a CSV, because CSV will keep the table formats.
Okay.
Does that make sense?
Yeah.
All right. Awesome. All right, so that was just talking about the data type of JSON, but it's really just a giant nested dictionary. And now how we can get these JSONs from the internet is using APIs. And so APIs stand for Application Programming Interfaces and are very, very important. They allow everything on the internet to play nicely with each other and work together. So APIs are super common, and there are many, many different kinds of APIs. The main purpose we're going to use APIs for is to get data. But APIs exist in other forms as well. You can actually have like models on hosted on APIs as well. So if you imagine like, let's see, if you had like a Pokemon Go. Are we familiar with that game? So Pokemon Go has many different aspects to it, right? So it has like a map function because it like sort of has to track where you are. And so to track that, I don't know how they're made, but very likely they're using some sort of location API that it can get information about where you are, and also like based on your location data, they can like plot on a map where you are, if that makes sense. So basically it means that you don't have to save everything on your local app. Just building in these functions that can call on APIs saves a lot of space on your device or on your computer. So that's like one way APIs are used.
So now if let's say there are multiple APIs into a single application, and, I mean, and then like if we are, for example, like the New York Times, which the one which we have, they would have probably multiple APIs for right getting all the data.
Yeah, very likely apps probably use more than one API. Because you don't want to like hard code all of the, you don't want to have all of the things stored on your phone or on your or in your Jupyter notebook, for example.
So does it work similar to the plugins on the websites?
Not too sure how plugins work, to be honest, but I would think so. The concept is the same. The concept is like you need something, but you can just ping something else to get it instead of like actually downloading it.
Okay.
Yeah. All right. So, but the main reason we use it for is to just get data. So API has three main components. You have access permissions, you have the requests, because what you're asking for, and in our case, we're asking for data, and requests include methods and parameters we will talk about later, and also a response. So we make a request and then we get a response. So cool. The main point of this is to understand that like APIs let us interact with third-party software or services, and services being like data owned by other people. They consist of a request and a response, and also access permissions. So New York Times has a bunch of different APIs. And in the future, when you have to come up with your own projects, you're very likely going to look for places that have their APIs, that have different APIs, so that you can get data. So New York Times is pretty cool. There's like all sorts of different APIs. This is for like their bestsellers list. This is for, this is their movie reviews one, which I'm going to actually use today. Also really cool, they recently came out with like a COVID-19 API that you can get any data about I guess COVID-19 that the New York Times has. So like you could get like based on the date, how many cases and how many deaths. So that's pretty cool. And you just have to make an API call, which is what I'm going to demonstrate later, to get this data. And so that's how a lot of people are able to make like these COVID apps or COVID like dashboards or like, yeah, their own mini projects, because they can get the data from the New York Times API and other sources as well.
So if we make let's say a Jupyter notebook, and then like we pull in the API of COVID, for example, whenever New York Times will update their data, it will automatically get updated here on this?
No, so you will write code to get data, but whenever you do it's only when you run a query, you'll get whatever data exists at that time. And we'll look at that in a little bit as well. So back to where we were. This is the movie reviews API that we're going to look at. So their schema is on their website in the documentation. So I have stressed about documentation a bunch before. Documentation is extremely important, especially with APIs, because every API works differently. And with the movie reviews API, it basically tells you, all right, based on what information you want to get, how do you structure your API query? So let's take a look at this. This is their schema. As you can see, that very similar to the last one we were looking at. There's like status, copyright, results, and here it seems to be the information that we want. There's like the title of the movie, their MPAA rating, whether it's like PG or G or like R, and all sorts of other stuff. And let's just say I'm doing a project that I want all this movie data. So, all right, how do we actually get the data from APIs? So there is actually a built-in library in Python, but it doesn't work very well. So we're going to use this library called requests, and all the labs also use this library called requests. So whenever we're making an API call, we're going to use the request library, just import requests, and we're just going to do a .get. So how do I start? Like whenever I'm starting with an API and I don't really know what to do, almost every API documentation has an example call. So what I'm going to do is I'm just going to take this example call and I'm just going to copy and paste it into here. And the syntax is pretty straightforward. It's just requests.get, and you want to save that to response. So usually takes a couple seconds because it's getting data. Let's take a look. All right, cool. Response dot, actually no, let's do this first. All right. So when I print response, it gives me a response 401. And so response by itself will give you a bunch of response codes. And so let's take a look at what response codes are. Has anyone heard of like a 400 or a 400 error? Error 404, that might sound familiar.
404 is the usual one, right?
Yeah, I think 404 is the most common one. But anyways, so response codes are universal. And thankfully, we can just go onto Wikipedia and see what 401 means. So let's take a look at these status codes. And 401 says unauthorized. So basically what they're saying is that we're not authorized to use the New York Times API. And through a little bit of investigation, most APIs require you to have some sort of API key. There are a lot of free ones available. Like for example, the New York Times one is free. But yeah, and there's some that you have to pay for. So somewhere on the New York Times API, there's a get started button, and they basically give you instructions on how to get an API key. And so I already did this, and I know that my keys live here in apps. So a lot of APIs need you to do this to like, just so they know what you're using their data for. So I just like made up that I was doing a New York Times study. And once I just like told them I was doing this project, and literally it was like immediate approval. They then give me this key. So here now I have this API key, which I can copy. And just by looking at this URL, you can sort of tell that you're doing some sort of search for Godfather, and the API key, I'm just gonna guess, just based on looking at it, that I would replace your key with my API key over there. Let's see what that does. Cool. So now we see that we have a response 200. And going back to our list of status codes, we can see that 200 is okay. So that must have worked. But response 200 isn't really anything. So what you can do is response codes dot, I think it's .json. And it turns your response into a JSON. So as you can see, the search terms here they were querying for just Godfather. And you can sort of see that these are apparently movies that have, I'm guessing, the word Godfather in it. So let's see, there's Godfather there, Godfather here. And so yeah, we have some data. And this is basically movie reviews on movies that have the word Godfather in it. So we've got some data. And so once I get this, I can basically save this response.json to like a variable called data, and then you can start your data cleaning process. All right, now, quick thing, API keys. So this API key, it's a convoluted string for a reason. It is basically your password to be able to access the API. And so just to be safe, I don't actually want it to be on my Jupyter notebook. I know for like certain APIs, you can get in trouble if they find that you've put your API key up on like GitHub. So if you had like your API key on a Jupyter notebook and you like push it up to GitHub, and let's say like a company finds out that your API key is there, they can, I think, block you from their API. I don't remember which company did this, but I've heard of people getting blocked from APIs because their API keys were found online, where basically anyone can just like get their data for free. So you really want to avoid that. So it's very important that your API keys are not visible on your notebook. And I'm going to walk through one method of how you can do that. But also in the labs, there is a different method of doing it. So in the labs, the method of keeping your API key secret is you're creating like a file on your local computer to just store all your passwords. And then no matter what project you're doing, you would go back to that folder and find whichever password you need. The way I do it, and it is really up to you which way you want to do it, doesn't really matter. The way I do it is I make what's called a config file to store passwords. So basically how you do that, and let's just read this really quick. Never hard code API keys and passwords into your main file, and because they will be vulnerable to attack, and so assume that if you put sensitive information publicly on the internet, it will be found and abused. So therefore, what I do is I create a config.py file to store my passwords and then create a git ignore. And I'll explain both of them right now. So first what I do is I'm going to create a config file. So what I'm going to do here, I make a new text file. I'm going to call it config.py. And then what I want to do now is, let me just take a look at what I did here. Here I did yish key and yish secret. So all you have to do is just put two variables in this config file and assign it your API key. So let's go back to this, copy this key and put in here. And since they gave me a secret, I don't know what it's used for, but since they gave it to me, might as well just save it here as well. So I'm just going to save this and close it out. So once you have that, it used to be called config2, but so now that I have those saved over there, I can now import yish key and yish secret from config, which is pretty cool. So if I run this and take a look at what my key is, you can see that it's actually stored in this variable now. So that way I don't actually have to type the string out here anymore. It's just whenever I need to use this key, I can just use the variable instead. Any questions about this?
Yeah. What happens when, let's say now I'm going to, if I clone, I fork and clone, will the config file also get cloned?
Yeah, so that's actually the next part. So first part, you have to put it on a config file and pretty much remember never to do anything like this, and not just basically you don't want to have your key be visible ever. So I'm going to get rid of this. The next thing you need to do is to create a git ignore on your GitHub repository. So I don't know how many of you have seen a git ignore file, but if we go onto any GitHub repository, there's usually a git ignore file. Let's just take a look what's in this one. So this is just from an API lab. And in the git ignore, you can see that there are all these files. Do any of these look familiar to anyone? Sometimes, yeah. They might not show up on all your computers, but basically these are files that are completely useless. These are just files that are like created by our system to like, I don't know the theory behind it, but think of it as like cookies for your browser.
I've seen checkpoints, but not the other ones.
Yeah, so these IPYNB checkpoints are automatically created by your Jupyter Notebook. They don't mean anything. You can delete them and nothing will happen, but they just help like create these checkpoints and just like, it's sort of like auto-save. But they don't really do anything to or for your Jupyter Notebook. And so why you're doing this git ignore here is such that when you do your git add, commit, and push, even though those files are always automatically created on your computer as you're working on something, it will never push the file back onto GitHub. So none of these files are ever going to turn up on this page, even though they might exist on your local computer. We're actually going to talk about this again next week when we start working on the project, because I'm going to have you all make a git ignore file. But basically how you would prevent this config.py file to go onto GitHub is you would just, in your git ignore, literally add config.py, and your config.py will never turn up on GitHub.
Can you, once we create the config.file, and this git ignore is automatically created, or we need to create a new file or folder for that?
We need to create the git ignore as well. But it depends on, like, sometimes if you're creating a repository on GitHub, they'll do it automatically for you. But you just have to make sure that config.py is in there. But yeah, don't worry too much about this. I will go through it again next week.
Yeah. So I have another question though. Suppose you want to, you're always accessing APIs, so you want to create a config.py somewhere else on your machine, maybe not even part of your GitHub repository there. Would that be a good way to do it? Then tell Jupyter go to this other file locally to do it?
Yeah, absolutely. That is actually the method that is outlined in one of the labs here. I think this one, they actually walk through, let's see what it is. I think in this lab, they walk through how to do exactly that. So let me see. Maybe it's not in this one, but one of the labs does walk through that exact process of like storing your API keys, not in your repository, but you actually have like one folder on your computer that's separate from your repository, so you don't have to worry about like not pushing it up. Yeah, I don't remember which lab it is in, but for me, I just like to, you know, when I'm like importing my keys, I don't like to have to like go to like the specific path and look for the file. So that's why I always do it per project. But it's really up to you. You can do either, both, whichever. But yeah, so those are a couple segues, tangents, and let's go back to our APIs. So as I was saying, instead of like printing your API key, what I'm doing here is I'm doing a dot format. Not sure if, I don't think I've talked about dot format with you guys, but dot format basically, it will look for any of these like curly brackets that are in a string and replace these curly brackets with whatever variable here. So therefore, actually, let me just print this part out so we can see. So this, with the dot format, automatically places my key there. And so if we have this in the response, that should be fine. I can do response.json, and I have all my data here. And my key is not on my repo. It's all right. So let's do something a little bit different and something that might be a little more relevant. Let's just pretend that for whatever project, I want to get movie reviews from all the movies that were released in 2020. So all right, how do I even start? Because I know that this URL only got me like all the things by Godfather, and I can guess that like if I were to like change that query part to like, I don't know, I can't think of any, if like a movie with like the word super in it, it would do that. But how can I get all the movies that are released in 2020? So if you ever need to do anything, consult the documentation. So let's go back to, let's see, I had the movie here, the movie reviews API. So honestly, I only found out by randomly clicking on links. So let's see, all right, get movie reviews that are critics' picks with Big Lebowski in the title. All right, get movie reviews with Big in the title that opened in the US between 1980 and 1990. So that sort of gives me a hint like, oh, I can actually like filter by date, and that could be something useful. So I know that this can sort of be done, but I really only need any movie that was released in 2020. So let's take a look. Let me see if it's on this page. Review, search. All right. because I've like looked through this and I've clicked through all the links, I think it's in here. So all right, you have this HTTP request and you can have these query parameters. And basically all of these parameters are anything that I can put into here. And so the way this particular API query is structured is that every query starts with this URL. So it always starts with this and has this, it ends with like this search.json. And so it does take a little bit of like reading and getting used to. Like I actually spent like maybe like about an hour like reading all this documentation to figure out how to structure my API query. But I basically figured out that you just need this section, sorry, not including this question mark first. You need this section, make it a little bigger, and then add a question mark, and then followed by all of these parameters. So as an example, and I hope they have examples here. Let's make this a little smaller. All right. So I know that query parameters, I can do like whether it's a critics pick. So I would do critics pick Y or not. I guess Y if you only want critics pick. And here, this is the one I'm going to use, opening date. And so I'm going to use the opening date parameter. And it says it's a string. And the start and end dates are separated by a semicolon. So if I needed like a range of dates, I would do it like this, 1930-0101 to 1940-0101. And if you want it open-ended, don't set an end date, which is perfect because I only want movies that have been released this year. So because I know that I want the movies that came out in 2020, how I structure it is after the question mark, I do the query parameter equals my search term, that date in the exact format that they want. And API key is actually a search, it's actually a search parameter as well. I'm not sure if it says it here, but yeah, you always have to have your API key there. But let's say I wanted to put another search term. So let's say I wanted it to only show critics picks. So what I would do is I would take critics picks and it says that it only allows the value Y. So all right, perfect. So how I would structure that is I would put ampersand critics pick equals Y. So this is what is called, it's not a URL, but a URI, because it's a resource identifier, a uniform resource identifier. And so just to make my life a little bit easier, the order of your query parameters actually don't matter, but I always put API key at the end just so I can just do the URI plus my key. And so I don't have to like fit in my key in a specific spot. But really quickly, let's just take a look at this. And let's first take a look at the results. Awesome. So these seem to be movies that came out, was this what, yesterday? Oh, tomorrow. This movie comes out tomorrow. And it already has a review up on the New York Times. So I think it was Kishore's question. Whenever I make this query, it depends on what data exists in their database at that time, then I get that data. So that's why I can get movies that I guess they've already released these reviews. So therefore these reviews exist in their data set. But if I were to do it maybe tomorrow, there might be new data. That's about like updating the data. But cool. So here, I don't really care about the critics pick thing. So I'm just gonna take this out for now. And I think if you see, let's see what these movies are and let's see if it's different. So this one is She Dies Tomorrow. This is Palm Springs. Palm Springs is a really good movie, by the way, if you guys haven't seen it. And The Old Guard, also a good movie. So let's see. All right, so these are different because those were the ones that came up before were critics picks, and these, I guess, include the ones that aren't as well. So you can see these are the text collector, Psychomagic. Yeah, so these are all just like, it's a different data set because this includes non-critics picks as well. And so that's how you can see like the different query parameters change what data you get. So really quickly, let's just do some exploration in this like results. The length of this is, I think it's 20. So you can get 20 results at a time. And each of the results has these keys that looks kind of important. And as we did before, we can just turn that information into a data frame. So here we have the first 20 movies that we've pulled out, and you have all the information here. None of these, I mean, it's possible that you're gonna have to unnest some dictionaries if you want, but in this case, I think it actually looks fine. Like, I don't think any of these nested ones are all that important for now. So cool, so this is how you can get data from an API and have it, one, locally on your computer, and two, maybe in a data frame. But now, and I think this is the last thing I'm gonna talk about, is this API call only gave us 20 results. And what are we gonna do with 20 data points, right? And so something that almost, I think pretty much every API has, is something called offset. And the process you would do to get more data is the process of pagination. And pagination is when you put the blocks of data together. And so how this works is you're gonna offset your query by 20 each time. So in their database, the data is ordered. So they're always giving you the first 20. So what you can do is offset and get the next 20 and then paginate them together and just put them together. And so if we look into the query parameters, there's actually an offset parameter right here. And in their case, it says must be a multiple of 20. And it sets the starting point of the result set to either 20, 40, 60, 80, and used to paginate through results. Cool. So just to test, if I do an offset by 20 and run the same code again, but instead with the offset, we can see that, let's see, the first one that came out was the tax collector, but the first one that came out here is a different movie, Retaliation. So that sort of tells us that it's a different set of movies. That's all, and that's what we want. And so all we have to do is keep editing this offset part. So if I do offset 20 starts with Retaliation. Let's see, offset 40 should be, yeah, it's the truth, another different set of movies. So what we want to do is we want to take each 20, we get 20 movies at a time, and we just want to put them all together. And so this is a way to do it. I wrote a function that basically takes a number. I was being a little lazy, so I used n, and where n by 20 is the number of reviews that we want. And I just create a list to store results and loop through the range of 0 to n, so 1, 2, 3, 4, 5, all the way up to n, and just do these calls and then add all the results to a list. So let me just run this and explain what was going on. So here I did reviews 4, so therefore n by 20 is the number of reviews we want because it's 20 every time. So I'm gonna get 80. I'm gonna get 80 reviews here. So it's gonna take quite a few seconds to run. And you can see here that I have now 80 movies. So what was going on here, this is not conventionally the way you want to do it. So what was happening is, well, what you would want to do is you would want to format this URI to be able to take in the offset and change that every time. So you can see that n by 20 is here. Yeah, n by 20 is here. And then should it be n or should it be I? Did I mess this up? Anyways, never mind. The offset number should keep changing. And then what I'm doing is I'm taking it and adding that data to this results list. So why I have an if-else statement is I couldn't get it to work for offset equals to 0. For some reason, when I was doing offset equals to 0, it was giving me nothing. And so I was missing the first 20 pieces of data. And so therefore I started with just the regular one without offset, and then I added on the offset part. Does that make sense?
How do we find out like how many data is already available? So if they say that every 20 you need to do, there has to be something where we need to.
That's a really good example. Sorry, that's a really good question, because actually that's not something that I usually mention when I give this study group, but there's actually there's a parameter in this API. There's a parameter that says has more. And so you can technically check if there's more, you can keep running the loop. So you can probably put like a while loop or something, or doing like while has more equals to true. You can keep getting more data. But yeah, that's only if you know that, you know, the data does end. You don't want to end up like getting every single movie review ever written for every movie, because that's going to break your computer. But yeah, that's a really good question. For this specific API, it is, you know that because of this this key over here.
But then we would not be able to figure out the exact number of movies that has been released, right?
It depends. It does depend on the API. I know, like, I think Yelp's API tells you how many businesses, if you like, for example, you're looking up businesses on Yelp, I think Yelp's API tells you how many businesses match your query, and you would do the same process until you hit that number. But usually, if you're using an API, there's so much data that you actually want to like come up with a number to cap your data. So like if I was doing this like project on New York Times movie reviews, I would say, okay, I just want to look at like the most recent like 10,000 movies, and then do my project on that. Because doing a project on like all movies of all time also doesn't really make sense. Or it might, I don't know, depending on your project. But yeah, you also want to be very selective on what data you're using, because you don't want to use all the data. But yeah, so with regards to the project, I know we're almost at time. With regards to the project, you can totally use an API, and I will tell you which APIs that are like easy to use to get the data that you're going to need for the project. So yeah, you can choose to use this because you have a lot more control over getting like the data that you want. I think the project's data is outdated by about a year or maybe 2 years. So yeah, this is definitely an option, and I'm happy to help if you want to do that.
So now, I mean, how many varieties of API that are available? So now, like free APIs I'm talking about. So how do we, right? We just need to Google and say that, okay, free API is available.
Yeah, there's actually a website called, I think, rapidapi.com tells you like it's basically a source of API. So like, let's say you want to work on a specific kind of project, you can look for API. So let's say, I mean, just looking at their popular APIs, you can see that you can look at like, all right, there's a Google Play Store like review. You can get app reviews and app data. Recipes. This is actually a very common one. Like people like to do like food projects. You can get like different kinds of cuisines, calorie counts of different things. And so a lot of students' projects use like, they'll look at APIs. Or if you have a specific thing in mind, you can search for, let's say you want to do music. So you can just literally Google like music API. I guess you can find it. Spotify has an amazing API, very easy to use. So yeah, Spotify is there. So if you have a project in mind but you don't know where to get data, this is a really good place to start, just by like searching to see if there's an API that can get you that data. Any last questions?
Yeah, that should be fine. Henry, for your food, it's there already.
All right, I unfortunately have to go and do another study group right now, but have a good night, everybody, and just as usual, Slack me if you have questions.
Yeah. Thank you.
Bye.